to the cloud.
Great. So hello, everyone. Hope everybody's doing well. So we'll get started with topic in hand today, which is essentially sharing different kind of at a high level career paths within analytics. So for those that are, new to the field, or if you're thinking about going into the field, you can kind of get an idea here. What are the career paths that I have an option to choose from? Because even though analytics is like it's a panacea term everybody uses, but there's different kind of areas of focus within the field and subfields, and in terms of how different companies actually use it and how they kind of structure teams, obviously depending on the size. So we'll try to cover some key basic roles that are that are part of the analytics kind of space. So with that, so a little bit about me. My name is Ali Rizwan. I've got 17 years in the analytics space. Graduated in 2005. I started my career off at Accenture, and then I've been building kind of data warehouse applications since then, working for kind of various companies, some work in the government industry, in the government industries. And then more recently, it's been a lot of healthcare focused, but basically the function's still been the same as far as, building data warehouses, building analytics applications, companies that are trying to automate and modernize their architectures to kind of get to insights without manual intervention. So the next point I have is like, why am I in this field? It's a little bit of an opaque answer, storage costs versus actionable insight. What I mean by that is kind of when I started my career out first, earlier projects I did, even when I was in college, I was doing internships. Kind of I noticed, within those internships and projects that how cheap storage is getting. And it was just an occurrence to me when at a particular instance that, hey, like storage is getting extremely cheap. What a gigabyte of like a flash drive back like 15 years ago was like $60, and now people are like giving a terabyte flash drives at like conferences if you go to it, right? So over the years, the cost of storage has reduced significantly, but in terms of the intelligence that companies are able to get out of it, that's still a challenge, right? Because even though companies are storing a lot of data, how that data is interpreted and made sense of, it's still there's a lot of work there. So I kind of sense there's a need for that, and I kind of invested kind of time, resources, and energy into this field. And I feel like even like 15 years ago, when I kind of started my career out, that's still the case today, right? So even still, you've got that need as far as there's a lot of data, but in terms of having actionable intelligence on it, that's still a challenge. So, so as we said, we'll kind of with that kind of backdrop in mind, we'll kind of cover the roles in the industry, how each one of them adds value to a business, and also, for you guys to get an idea, hey, what does actually like a data engineer, for example, does in their day-to-day duties, right? So how does that data engineer, like if you're trying to get into the field, what does that person actually do, right? So I'm going to jump right into it, right? Like a data engineer, right? What does a data engineer do? Okay. So when you think about a customer, right? Like we go to a Walmart or we go to any like retailers, or we have interactions with the company. When you're kind of scanning items from the Walmart, kind of the self-checkout kiosks or wherever, each item you're scanning, it's going into some database, right? It's going into some system, some back-end applications that's kind of tracking what was purchased, right? And then eventually that's going to get rolled up into, the company's going to want to know, hey, what did I do with it? And that's just one of many, many applications, right, a company might have. So the purpose of a data engineer, right, for a given business, what they do is what I have highlighted here. It's the word ELT, right? So if you're trying to get into the analytics field, or you're in it already, like, this is a word that kind of comes up a lot, right? What that means is extract, load, and transform, right? So if you are a Walmart, for example, that data that the application's collecting, that goes into some application. A data engineer and their job, and likewise, you're working for a company, they may have many applications, many places data is coming from. The job of a data engineer is to take that data and bring it in-house. It's to bring it into this thing called a data warehouse. So, you might have data in kind of multiple sources. What a data engineer is doing is that extract and that load piece. So when we talk about ELT, we're talking about extract, load, and transform. But really what a data engineer is doing is that extract and load piece. And so I know this might be a little bit of like an opaque concept. Does that make sense to you guys? Does anybody have kind of questions on it so far? Okay, I'll take that as a no. So, so in terms of like what as an example of if you're interested into this field, from my experience, from my personal experience, yes, when people think about analytics, a lot of times they think about like AI and they talk about like like cool applications. What maybe you've seen the Netflix series on that Go application, and somebody created an application, like a transient application that could beat the most famous Go player. Like, that's what you think about when you think about like analytics and AI. Like majority of the work and money and time and effort that companies spend is not on those like glamorous things, right? Most of the time, energy, and money people are spending is in just a bunch of data engineers taking data from CSV files, JSON files, be connecting to like a Salesforce or some other applications you're running, and they're bringing that data into a warehouse, right? Like, that's where most of the work is. And now what I would even kind of venture out to say or suggest for those of you kind of looking to get into the field, probably in terms of the roles that you're seeing, right? What if you go onto like a job board and you look for a job or a site, right? And you're saying, hey, let me put it on Indeed, like analytics jobs. Pretty much every company is going to have a department that does this, right? Because before you can do anything else with the data, before a data scientist gets it or an algorithm gets it or it ends up in a dashboard, it's going to have to go through here, right? So this is, and I don't, honestly, even though technology and architectures are changing, right, in terms of how data warehouses and data lakes are put together, this need of getting that data from multiple places and kind of putting it into a warehouse is like pretty much always going to be there, right? Like, I don't think that's going to change. So if you're looking to get into a field, the role of a data engineer and what they do, it's very key, right? Now, if you want to get into this field, what are some of the kind of tools and platforms you need to know about? Well, so even though this topic is about analytics, it kind of bleeds off into the topic of like cloud, because a lot of the applications that do this function where a person has to kind of connect to different data sources and bring that data, into a data warehouse, they happen using tools in the cloud. So you have tools like Azure, Amazon, the Google Cloud platform that have their own tools, and among many other, right? So, and I didn't list like the different tools that are available. That's really like a much more kind of technical discussion, and maybe we can do that like a deeper dive into these roles. Like, hey, for a data engineer, if I want to get certified and become or spend time investing to become a data engineer, what it is, what type of tools should I focus on? What type of certifications I should get, right? Like I'm not going deep into that here, but know that, hey, you know, the purpose of this is just to explain, hey, what a data engineer does, but then, okay, how to do those things and what tools to do those things in is a separate discussion, which, you know, depending on, hey, is the company you're trying to aim for or the market you aim for, are they running Azure? Are they Microsoft shop? Are they, and, you know, an Amazon AWS shop? Are they running Google? Even though I would say Azure and AWS are like the big dogs, you know, Google's catching up, right? So which tool do I want to focus in? That becomes another discussion. Azure has its own, AWS and Google, and so on and so forth. So, but in either of those tools, if you think about a day-to-day activity a data engineer would do, I want to walk you through that, right? So, what you might be doing on a day-to-day basis as a data engineer, right? You might be, let's say your company gets data from different vendors, right? Let's say you're a big company and you contracted it with a vendor that runs online campaigns for you, right? So their job is to kind of run your campaigns, and you know, for those campaigns, they kind of collect the data and they send it over to you. Hey, these are the campaigns that are running on your platform. And let's say, you know, data like a terabyte data comes in an hour, and let's say you're running 6 different campaigns. Now, campaign 1 might be like a CSV file that they're sending you. Campaign 2 might be a JSON. You know, campaign 3 might be an XML. It might be different file formats. Campaign 1 may have a different naming convention. You know, campaign 2 may have a different naming convention. Your job as a data engineer, you know, would be typically, okay, you figure out where that, whoever that vendor is that's sending you data, where are they dropping it, right? That file might be dropped in some SFTP server. You have to figure out, you know, as a data engineer, okay, how do I connect to that using any one of these tools? And then from there, you have to kind of read the data, kind of figure out how to make sense of it, because campaign 1 may have different columns, right? You think of an Excel spreadsheet, right? Campaign 1 have columns A through C defined. Campaign B may have columns A through, you know, W defined. Column, you know, a campaign C might have columns A through F defined. So depending on that, what that campaign is, you have to write jobs, or you have to help the company kind of automate the process of picking that data up, figuring out what format, figuring out what columns are coming in, and then figuring out based on the campaign where to dump those so that people downstream can start using them, right? Because like I said, data engineering is the beginning of the road. And then you've got other people that are going to use the data. So, you know, when you're thinking about data engineering and thinking about tools, like kind of keep that in mind. So any questions on that? I know that was a lot.
Feel free to turn on your mics if you have a question for Ali around the data engineering piece.
Yeah, so basically a data engineer just maps out how the data goes from one place to another, right? That's what you're saying?
Yeah, mapping is maybe a generic term, because mapping other roles do as well. It's mainly, think about that before the data engineer gets their hand on the data, it's chances are the data is sitting outside your organization, or it's not in one place, right? So if you have a Salesforce app, you have a PeopleSoft app, you have, you know, some data running on some other platform, the data isn't distributed across multiple things. If you want to look at your HR data with sales data, for example, you may have an HR system and you may have a sales system. The purpose of the data engineer is to bring it all into one place, right? So typically companies have data warehouses, or modern day terms is data lakes, right? Where they just dump everything, right? And think about it, like maybe 20 years ago, how many pictures did we have, right? How much data that was generated was pictures? Probably not as much, right? So now you've got pictures, you've got, you know, text, you've got voice, you've got, you know, structured data, unstructured data. You have so many different applications. The job of data engineers is to just bring that data into one place. So now instead of it being in a Salesforce, in a PeopleSoft, in an SAP, in a whatever, it's now in one place, right? So there is a data duplication happening, right? And there's a whole kind of science around that, right? Because the data is in Salesforce and the data is also in your, data warehouse. How do you manage that? There's a whole science around that, right? So how frequently do you need data? Does it have to be every hour? Can it wait a day? Can it wait a week? Can it wait a month, right? Depending on what the business needs are. So it varies, but the ultimate goal, the data engineer is not really looking at the data as it comes in and saying, hey, what type of, how were my sales yesterday if the data is coming from a sales database? They're not really doing that. Their job is to just dump the data, right? They're not doing much of the analysis, right? So it's really behind the scenes work, but it's critical. It's like super critical. And most of the jobs you see, I feel, right? Like this is like a key function, which is not going anywhere.
Yeah, I have a scenario that I can tell you, Osama, is right now we're working on a consolidation project between our Stripe data, our data that we collect from our platform itself. So, like what plan level customers are. We want to see what plans they are on, how many times did their Stripe payments fail or didn't fail. And we want to see all that data within HubSpot itself. So then what we can do is start triggering emails and stuff. But the first step of the process was we needed to work with one of our engineers to establish the data pool and make sure that the connections were made between the different APIs of these different systems. So I may be like totally using the wrong terminology here, but from my understanding from working on the product and the marketing side, that's what I saw. That's the request I made. The engineers worked on it, and now we have a data analyst looking at the data, which I think Ali is going to jump into next. Yeah.
Does that answer your question, Osama?
Yeah, so I just want to quickly say something. So like I also basically I'm a marketing data analyst, so I do work with different campaigns, and for us, basically we give each campaign like in their own ID, and then through like SQL is where we create their database, but then we need to create that database into Excel. But also on the side job, what we're doing, we're automating these processes. So we just put the campaign ID into like SAP business objects, so the so the Excel can just automatically be automated. So I think that has some like, how does that connect to what we're talking about data engineering?
So it seems the fact that you have to dump data into like an Excel file, and then from an Excel file, it has to go into someplace. There's probably some manual steps in there, right? Where people have to drag and drop stuff. When think about data engineering and what a data engineer produces, it's the same steps that you're probably talking about, right? Where you've got, the data comes in, what Zohaib was describing. And typically, right? Their job stops once they bring that data in, right? They automate wherever your campaign systems is from SAP, whatever. Their job is to bring that campaign data in, put it in one place, and typically their job stops. But in the whole data pipeline, right? And I'm going to talk about this a little bit. In the whole data pipeline, wherever there's manual steps somebody has to do, right? If somebody has to go into an application, dump data into an Excel, and then dump it to another application every week, every month, every quarter, that's inefficient, right? You have to minimize that. You have to reduce that. You have to cut that out, because the amount any human, even like an entry-level person, is going to spend doing that, you can program it. It's going to be a cost saving, right? So this step, what I'm describing, is probably that campaign data being connected from whatever source it's coming from, whatever API it's being generated from. It comes into one place. If it's SAP, it comes into one place and it kind of just sits there. And then now I'm moving on to the next role. You mentioned company, like your company, somebody has to take that data. Chances are, if it's a campaign, you mentioned like you select, campaign 1 does this, or campaign 2 does this, and maybe you have to enrich it with some other data, right? You have campaign data, but you don't know who the customers were, right? Maybe they're just like maybe there's some abstractions around that campaign data, right? A lot of my background is in healthcare, right? So I guess we might have like claims data that comes in, right? So an insurance company sends us claims data, and that claims data maybe, we have to kind of, because, as a hospital, you have the patient record, but you don't have the claim information, right? So we get the claim information from the insurance company, but the insurance company sends their own ID and description of the patient, right? They may have a patient name, but then we have to match it with our system and say, hey, this person's Ali Rizwan, but the insurance company has it Ali Fareed Rizwan, or it's Osama Jaffrey, but the insurance company has it, a USAMA Osama, whereas we have it as OSAMA. So all these things so the data engineer may be taking that claims data and dumping it into one place, but then there's data cleanup needs to happen before he starts reusing it, which is the next thing I'm getting into. A lot of the new roles, and this is a new role, right? Like this data engineer, data analytics engineer, these were like blurry lines. And even if you go into some organization, it's small enough, one guy might be wearing like 5 hats. He might be doing all these roles one to end. But as you move to more progressively get more sophisticated kind of analytics shops, these are going to be separated roles because one person can't do everything, right? So a newer role that's kind of coming in that kind of sits between the data engineer and the actual dashboard or the insights is like analytics engineer, right? So they're really, so in your example, or the example that we're talking about with the claims, right? Once the claim data comes in, you need to map it with customer data, or you need to see, hey, I want to see the claims data. It's at the daily level. I want to roll it up at the quarter level. And maybe I want to look at only diabetes claims, right? And I only want to look at patients over 65 or something, right? And that who didn't come in for a A1C score last year. So, so like you see how now it's more like intelligence, right? It's more things. What do we need to do with the data that's come in? Typically, the data engineer is kind of behind the scenes. They're not really looking at the data like that. They're just bringing it in. When you get into analytics engineering, which is, like I said, is a newer role, they're taking raw data, the data engineers output, and they're taking it and they're working with the business to kind of come up with data sets that can be used to answer the questions that the analysts or the the business users are asking for, right? So in this diagram, it's the same diagram. The data engineer might be over here in the database side, but the analytics engineer is maybe the red box. They're the T, right? So the extract load is the data engineer, and then transform is the analytics engineer, which are taking the raw dumped data and they're writing queries on it, right? They're writing different, maybe a lot of it is SQL, because most of the data, that is being transformed and put into reports and dashboards, it's in relational databases. Most of the data warehouse that are going to be used for reporting, right, are still relational data warehouses, right? So I said I wouldn't get very technical, but basically these roles generally they're using SQL a lot more heavily, right? As you mentioned, right? Like you've got data dumped somewhere, you're writing SQL to kind of slice and dice it the way somebody's requested it, and then maybe you put it into another data set that then a data visualization person can use. Because now, okay, you've taken that raw data, you made some sense out of it, you created another data set, right? Now, typically when you want to present that, now you need to put it into a nice, pretty dashboard that somebody can take a look at. And every time new data comes in, just the data flows through, right? And it goes to that dashboard. So, the role that I've highlighted here in the yellow here is that data visualization piece, right? So from data engineer, it's the raw data in, you got the analytics engineer that's transforming the data, and data visualization person is kind of converting that data, that transformed data, into a dashboard. Now, a lot of data visualization experts, they know data well enough. They might know a tool. So when I say data visualization, I'm talking a tool like maybe a Power BI or a Tableau, right? So you're trying to create graphs and charts, and you're trying to create kind of summarizations of the data so that the data can tell a story, right? But a lot of those people, they have the expertise to even do the SQL, right? So, it's a little bit of a blurry line, right? Most people don't have it really split out into analytics engineer versus like a data visualization person that's just focused on that. So typically they're blurred in a lot of the organizations, but in the organization that I'm in, you know, we've got a separate role for like an analytics engineer that's just their job is to create the data sets, and then we give the data sets to a team like a data visualization team that picks it up, and then they kind of run with it. Does that make sense? So with that, data scientists, right? Like, so, you know, this particular role, kind of earlier on, most of the analysis we were describing, this is data that's already happened, right? These are things that are more or less like in the past. You know, data scientists are basically kind of their jobs is to like a typical life cycle, right? Like I would describe a project that one of the projects I'm working on, right? So one of our customers wants to know their leasing app, they have a leasing application. So they want to know, hey, we've got all this data, you know, sitting in our data warehouse about former leases, right? I have the data, but I really don't know who are my most profitable customers, right? Like I can know who are my most profitable customers, but what makes them profitable? Like what are the shared characteristics of my most profitable customers, right? So in that use case, you know, we're going in, we're kind of working with the customer and we're saying, hey, like, give us a data set, give us the data that you have, and tell us, how do you know the customer is profitable, right? So they tell us, hey, there's a event that happens, you know, during the life cycle of a lease. And if that event happened with a customer, typically that's like a renewal, right? We want to know customers that will renew, right? So if that event happens, we want to know which customers are the most likely to renew, right? So typically the life cycle of that a data science project, in our case, right? Like we're working with them to create a data use case. And the data use case is data that's already happened in the past, right? That we've got some data, historical data about customers, right? And we're trying to aggregate and analyze to see, hey, what are the common things? What are the common things, buckets of customers that lead to this event happening? Now, so think about that, right? Like in that case, I really don't know in advance where to look. I might have certain assumptions where to look. I might be like, you know, let me look at industry. Like maybe there's some pattern by the industry. I may say, and maybe it's the type of equipment that they use. Maybe there's a pattern by that. I might say, you know, it may be the type of lease it is. Those are kind of common guesses, right? But then when you do the analysis, right, based on that, let's say you do the use case development, then you collect the data, right? You collect the data based on the use case, and then you do the analysis, but the analysis tells you, hey, month is a really strong indicator. When the month of the lease starts, if it ends up on a quarter, a lot of times customer renew, you know, when the lease ends on a quarter. I didn't know that before going in. When we're talking about analysis that like data visualization or analytics engineer does, the business user is saying, hey, give me my data by customers, by this industry, by this lease type, and by this month, I want to look at that. Whereas this question is like more vague and open-ended. I'm like, hey, tell me an event that's going to happen, right? And tell me what leads to that event, right? So the data scientist, when we talk about like the next role I'm going to talk about is the data analyst, right? When we talk about analysis of data scientists do a lot of that in their life cycle, right? Because think about it. If a customer says, hey, predict this event, you're doing a lot of that analysis when you're looking at the data. Hey, does this field have any correlation with the event that I'm trying to predict? Does this field have any correlation? So it's not a pretty much most jobs, like most roles, like analytics engineer also, and maybe some data visualization, they're doing some analysis, right? When you're writing a query and we're looking at the data, you're doing some analysis. Probably the data scientists do a lot more of that, I'd say. it's just given the life cycle, right, of the project, because you have to determine, hey, this is the data that I have, is it enough for what I need? So, they're doing the analysis, and then if the data, let's say the data doesn't point to that. Let's say I have the month, I have the lease type, I have the industry, but when I build a model, it's like a 50% accuracy, meaning you could flip a coin and you'd be just as accurate if, you're going to have a customer renew or not, right? So that doesn't tell you anything, right? So at that point, you need to go back. You'd be like, hey, customer, you gave us this field, this field, this field. There's no correlation with the event you're trying to predict. Maybe we need to look at something else. Maybe we'll look at, how long they've been a customer, right? Are they a new customer? Are they an old customer? There might be other feature engineering I have to do. Maybe I have the date of when the lease starts, but maybe I need to look at the quarter. I need to extract that from the data that they've given me. And then you get to maybe a model that's usable, that you can evaluate that, hey, I get a model that's maybe 90% accurate, right? So it's accurate 9 out of 10 times, great, right? Now, in a lot of cases, 9 out of 10 is great. In some cases, when you're talking about making trades using the output of a model, if you have $1 billion trade and it's wrong 10% of the time, even if it's wrong 1% of the time and it is wrong, that's $1 billion you lose, right? So there's so then the cycle kind of starts back up, right? Like the model is giving us this much accuracy. Is that enough? Is that enough to deploy the model and put it into production and use it, right? The example most of you guys might be familiar with might be like the Netflix example, that hey, Netflix engine is giving you recommendations of what movies they think you'll watch. They've got thousands of titles. They want to make sure you spend as much time on the platform as humanly possible. And based on that, their algorithms are tuned to give you recommendations where you'll be most likely to click. If you don't click on a recommendation, it's not like the end of the world, right? Like it's not, their models can be wrong as well. It wouldn't be like a big deal. In other cases, like with the Tesla example, right? Like if your car is driving and it's like wrong and and it misjudges where it needs to stop, right, the auto driving, there's big ramifications for that. So depending on from the use case all the way down to model development and evaluation, like that's kind of the general that's a very interesting life cycle of data scientists. Like this is where But I will still say, like, the application of data scientists in like broader corporate America, it's like still like much smaller percentage than the people that need data engineers. Like you have the big names like the Amazons and the Googles, they're like the forefront of like AI and using data scientists, but majority of companies in America, like they're still trying to load like Excel files into a data warehouse, right? Like that's just the reality of where analytics is. But, it's like, it's still things are maturing where like, and the reason for that is because a lot of what value a data scientist produces is based on how good the business tells him the use case is, right? The business has to tell him, hey, this use case is very important to me, produce something from it that's usable to the business in order for all the technology to make sense. That's true in most cases, but I think I've noticed specifically with the data science role that's very pertinent. Any questions?
Yeah, I was just mentioning data scientists are one of the more expensive, personnel to have on the team. And actually, like our CTO and myself, we actually write up and do a lot of the data modeling and stuff like that, just because we can't afford a data scientist. So if that is a career choice you want to make in terms of trying to make money, data scientists do get paid pretty well. I just wanted to throw that out there.
I've noticed though is like companies often, there's like a push that, hey, like, Google and Amazon are doing this, we need to get a data scientist, right? And they get a data scientist for a PhD from some university, and they're just like twiddling their thumbs because they have nobody to tell them, hey, I need this question answered, I need this question answered. So a lot of time I've seen the other side as well, where you need to have an engaged audience on the business side. Hiring a data scientist, unless you have, as Zohaib mentioned, that on the other side, people asking questions, is not going to do you much good, right? So as you definitely, this is a very like I would say a lot of these fields are lucrative, right? Depending on at the level you're doing them. But yes, data scientists, tend to demand a very high, you know, like salary packages and stuff. But for a program to be successful at an organization, you really need like engagement with the business for it to be successful, right? So when if you go into this field and you're making a decision where to go, you might get paid a lot of money someplace, but if they're not using it, you're going to be like bored there, That's just a one-off. So I think somebody have a question?
No other questions relative to this slide.
Okay. So the last, I was going to go into the data analyst role. So these are kind of the people that are kind of looking through the data, and we're talking about looking through for insights, from the data. And I know we mentioned a few folks on the call that work as like analysts. When I talk about most of these roles, right, starting from the data engineer, analytics engineer, data scientists, these guys are working with specific technologies, right? There's a Python, data engineers are using Python, they're using SQL, they're using ADF. Analytics engineers are using, like a lot of SQL. You got tools like Power BI and so on. Data scientists, a lot of it is like math, and you got to know how a lot of the coding is done in Python, for example. I feel like from a data analyst, it's not as yes, you might be using like SQL or you might be using Excel to do analysis, but whereas I feel that like a data engineer, analytics engineering, or data visualization, data science, there's certain tools you can learn and become one of those roles. Whereas I feel like a data analyst, like I could sit today in my laptop and study how to be like a SQL developer or a Python developer, or write reports in Tableau or Power BI. A data analyst is not something I feel like you can like really technically train for, right? Because a lot of it is you understanding the industry and understanding the business and how that that business operates, right? It's accumulated knowledge over the years of how that business runs and functions, right? So most of the people I see are data analysts in companies. They've been there for a while, right? They've been there for a while. They know nuances in the data, right? And they know how to make sense of the data, right? In other cases, they may know how to ask the right questions, right? So a lot of it is more your knowledge of the business, right? That makes you become a good data analyst, right? As opposed to technical knowledge, right? But they're like invaluable, right? Like, because a data engineer or an analytics engineer, they would not know like where to look, or typically you're working with data analysts that are asking the questions, right? Hey, we need this to answer this question. They're asking the questions and they're collecting the data to based on their business knowledge to make decisions based on the data that's provided. So it's not a role if you're like new to the field. I feel like in isolation, without being at a company, you can be like, hey, I want to be a data analyst, and just like read a bunch of articles on and become a data analyst, right? Like, I feel typically you have to kind of go within an industry, understand an industry, how an industry works, how like use cases within that industry works, to kind of get more insight into the business side of things as opposed to the technical side of things. Whereas the other roles are kind of like my domain, the data engineer, analytics engineer, data visualizations. I spent most of my career there. I work with data analysts, but I'm not typically the one. I'm typically more on the technical side of things, right? So that's just my kind of experience and 2 cents about that role. So yeah, with that, we'll kind of end it and go through the questions.
Awesome. So I'm going to read off some of the questions from the Zoom chat. Everyone, please feel free to ask more questions. We do have 10 minutes left. So One of the first questions was, what are the typical requirements that are required of a data analyst? Do they, you know, involve less coding than a data scientist?
So I would see, like, that's what I tried to answer a little bit earlier, right? Like, let me think how to answer this, because I think part of the question kind of implies what's like easier, right? Like it requires less coding, right?
Yeah.
So, and that's where the little bit of, because you think you have to add value to the business, right? You have to add value to the company for them to hire you. So if you're not doing it as a coder, what are you doing it as, right? So as a data analyst, if you're not an expert coder, right, and they're not bringing you in as a coder, they're bringing you in because you worked in some industry or you know some space really well, right? Where you can look at the data and you can make sense of it, you can ask the questions, or you can work with the data analysts to get to some insights, right? So I feel, because I mean, if you haven't been outside and worked, how will you be able to analyze the data, right? Like how will you be able to do it? You need some, like it'll be hard to do, right, in a vacuum. Like you need some kind of business experience. So I feel data analysis, and like I said, even other roles, right? Like as a data scientist, they're doing data analysis. The example I gave, where in projects, when you're trying to make predictions or you're trying to see, hey, which features impact the outcome of a model, you're doing analysis there, right? So somebody that's a data analyst and who doesn't have industry knowledge or some use cases that they've worked on and they don't know how to code, I'm not sure how like valuable they would be, right? And that's my opinion, right? Like that's just my experience.
Yeah, for sure. Personally, I've worked a BI internship before, and I realized a lot of what I had to do was actually converse with the sales team and the marketing team before I even went into the data and started visualizing it on Tableau, because it was a really big thing was, what do I even look for in the first place? Like I'm just looking at rows of data, right? But how do I make sense of it? Well, I needed to understand the business. What do you think that a good starting role, let's say you can't get a data analyst role, right? You want to break into the field. What do you think a good position might be for someone to enter into? Would it be like the marketing department, the sales department, etc.?
From a data analyst side?
Yeah. So because you mentioned that, having some sort of business perspective is helpful to getting that type of role in the future. What title should one who's like an entry level person, right, just graduated out of college, kind of apply to get in, break into that eventually, that data analyst role?
I would say probably obviously, like as a data scientist, you're doing a lot of that analysis anyway. I would say probably the least one would be data engineer. I'd say if you're doing more data visualization, that's probably a good role, because a lot of the data analysts that I've worked with, they're typically like really good users of like Power BI, right? They're spending a lot of their time, in those tools, looking at the data. Maybe somebody else creates the dashboards and they like modify them, but they know their way around those tools. I'd say of these roles, probably like data visualization, because you're looking at the final product that goes out to the business. Now, to be honest, like that's not a path like I've taken, right? Or I'm kind of talking about it from the angle of somebody actually being a data analyst that I've worked with. I don't know where they started, right? Like maybe they started in a warehouse someplace, right? And they just saw how the warehouse worked and they moved up into a data analysis role. Maybe they started as a salesperson within the organization and they moved into the data analysis role later on, right? It doesn't have to be from a technical role, right? Because people can be other parts of the business where they accumulated how the business works, and then they transition into an analyst role, right?
Yeah.
And they saw before when a new system was implemented, when a Salesforce was implemented, maybe they worked with the sales team to make sure that the CRM system was in line with what they needed. So they know the questions the sales team asked. They know the things that they go through. Maybe they used to, were in the healthcare, maybe a lot of them are nurses,
Yeah.
right? They were actually working in the field, as a nurse, so they know on the floor what happens. Right. And later on, they learn SQL and they move into like maybe an analyst role, and they're managing operations. Right. So I feel a data to make a jump. You could probably make a jump from like a data visualization person to like a data analyst role. But generally, I've seen data analysts come from the industry side. And
Yeah.
then they maybe pick up some tools like a Power BI, or they teach themselves SQL or a little bit of Python, because they don't want to go to the IT people every single time if they need something. They're just like, give me the raw data, I'll figure it out, right? So they teach themselves those skills to analyze data, but they know the right question to ask because they worked in the industry side someplace.
Yeah. Yeah, I've seen that myself. Yeah, I've seen that myself, actually. So this is for people who haven't, who are kind of working right now and have always been eyeing the data analyst side. I've seen that, Ali, like same thing. Like actually, one of my coworkers worked as a client success manager, taught himself SQL, started doing some reporting for the CS team on the side, and then they promoted him to the CS and business analyst, essentially making reporting and stuff like that on tools like Looker and Tableau. So that was kind of like a use case, and that's something that I want to jump into. Like you mentioned SQL. Now a lot of people in a lot ask what tool should I learn first, or what language should I learn first, or whatever. If they were trying to just get a teaser of what analytics is like, what would you recommend? SQL, Python, R? Those are typically a lot of things that are thrown out in a lot of these data analytics courses. What would you kind of use as your first primary tool?
So what I would suggest, if you're trying to get in and granted, you may need somebody to guide you a little bit on it, right? And that's why I have these like scenarios out here. I would say when you the short answer is probably SQL. Okay, SQL is still like the king, right? Like the better you are at SQL, it's not going anywhere, right? There's plenty of jobs and plenty of companies where if you know SQL really, really well, right? You can do a lot of things there, right? So I would definitely say SQL, but I would say SQL is usually not the only thing. It's like a starting thing, right? When you go for an interview, right? When you go to apply for a job and you go to an interview, they'll be like, hey, what did you do? If you say, hey, I know what a select statement is, they could care less, right? If you can write a select statement in SQL, they don't care. They want to know what problems you solved, right? For a business. So typically, when you talk about solving a problem for a company, you're talking about a scenario, and you're talking about SQL as one of the things that you used in a series of things to solve that business problem for that customer, right? So to the short answer, probably I'd say for a majority of you guys, SQL and Python. And I would say probably the easier one is SQL. So we start with there. But I would say SQL and Python, both, like, you can't go wrong, right? Like maybe like 5-10 years ago, it was like a lot of R too, right? A lot of folks use that, but I feel like for data science roles, especially for like big data analysis, like Python is like it's the one. So I feel like it's been consolidated, but like I said, it's more like SQL, but think about the problem you're solving, right? Think about what do you need to do end to end for a customer to give them some value, right? Because that's the goal, right? Like unless you are, like you said, you're already in some role within a company and you just want to like learn SQL or learn some analytics just so you can like manage your analytics team. And if they're trying to BS you, you know, hey, that's BS, you know, like it doesn't take that long. I know a little bit of SQL, right? Like if you want to learn like some analytics or SQL just for that, right? Then it's fine. It's good knowledge to have. But if you're trying to become like a developer that as day-to-day has a job, SQL is not the only tool you're going to use. You're going to use a number of tools together to solve one of these scenarios that I'm like listing here, right?
Yeah, for sure. So building block, you start off with SQL, kind of progress from there if you have more interest.
I would say SQL, but typically you want to align yourself to a platform, right?
Yeah, makes
Like,
sense.
That's more because SQL within Azure might be slightly different, and the tools that you use to implement SQL might be different, right? So you want to become like a Snowflake guy, like you are the Snowflake person, and Snowflake is a relational database that you have that runs SQL. So you know, you learn SQL, but you also run how the Snowflake engine works, right? Or you become an Azure person, right? Azure SQL. So you understand how to write SQL, it's T-SQL for Azure, right? Azure databases, but you then also learn how does the Azure database work on the Azure platforms? What are the different types? There's managed instances, there's SQL databases, there's Synapse, there's Hyper, you know, like hyperscale databases. So there's different databases. I would say focus on the platform, and then within the platform, then figure out how to use SQL within that platform, right? Because when companies hire, they don't hire for a language. They don't hire a Python, just a Python or just a SQL. They're typically an Amazon shop or, you know, AWS, or they're an Azure shop, or they're a Google shop, or whatever. You want to, I would say, align yourself to a platform more.
For sure. Awesome. Well, we're about to hit time. Ali, thank you so much for hopping on a call and educating all of us. We'd love to know, is there any way we can contact you, or you have a website that you wanted to share to everyone?
Yeah, this is my email. This is my LinkedIn cell phone. Just, you know, probably LinkedIn is the best way to kind of reach out and connect. You know, if anything I wasn't able to cover, or if you guys have other future things you'd like to cover that we couldn't get into, you know, we can hear your feedback there, you know.
Awesome. Well, thank you all for joining today. You know, I learned a lot personally. It helped me kind of visualize how everyone on my team essentially works, and you know, maybe I shouldn't ask for so many requests, because now it shows how much work a data engineer and a data scientist kind of has to do on the back end whenever I make a request. So that was really cool. I hope everyone else here enjoyed the kind of information that Ali gave us today, and hope to see you guys back again. And Ali, would love to have you back on another session in the future.
Great. Thank you, guys.
Awesome. Thanks so much, everyone. Have a great rest of your day.
Bye.